All right, today we're Algebra 2. We're looking at the second part of 4.3. Today we're going to divide rational expressions. Yesterday we multiplied. So to divide rational expressions, it says divide and state the domain. All that we do, since we would have fraction divided by fraction, or anytime you have fraction divided by fraction, you take the bottom fraction, you flip and multiply, right? You multiply by its reciprocal, so that's all that we're going to do here, okay? So I'm going to rewrite this very first thing. So the very first one, this one stays the same. I don't do anything with that. So I have x cubed plus 3x squared plus 3x plus 1. All of that over 1 minus x squared multiplied by this one, flip, x squared plus 3x minus 4 over x squared plus 5x plus 4. That's what I got. Right? So now I need to factor, right? Okay, this first one, x cubed plus 3x squared plus 3x plus 1. I have 4 terms. It's not going to factor by grouping. So remember how to resolve these? P's and Q's. Okay, so my P's and Q's, my constant term is 1, so that's nice. Positive, negative 1 over my leading coefficient, 1. I only have 2 options, positive 1 or negative 1. I will try negative 1 first. So I'm going to do negative 1 in my little box. My coefficients 1, 3, 3, 1. Negative 1, 2, negative 2, 1, negative. Yay, so then I get x squared plus 2x plus 1, which I can now factor. Okay? So this top over here factors to x minus 1, right? Was in, or sorry, negative 1 was in my box, so that came from x plus 1. So then factors, 2 sets of parentheses, x and x. What can I multiply together to get 1, but add together to get 2, plus 1, all over 1 minus x squared. I'm going to really make that negative x squared plus 1. I'm going to pull a negative 1 out. Okay. So if I pull a negative 1 out, I get x squared minus 1. That's a difference of squares. So that's x plus 1, x minus 1. Times x squared plus 3x minus 4. I'm going to factor that. What can I multiply together to get negative 4, but add to get positive 3? Positive 4, negative 1. Over on the bottom, what can I multiply together to get x squared plus 5x plus 4? So what can I multiply together to get 4, but add to get 5? Positive 4, positive 1. X squared plus 4, that is not going to factor. It's not a difference of squares. So now I'm ready to start crossing out, right? Anything that's like top and bottom. X plus 1, x plus 1. X plus 1, x plus 1. X minus 1, x minus 1. X plus 4, x... Oh. Not x plus 4. Let me... Oh yeah, this was an x, not an x squared. I don't know why I wrote an x squared there. That is just an x. Sorry. So x plus 4, x plus 4. So what's left? I have a negative 1 on the bottom. That's the only thing on the bottom. So I can bring my negative 1 up, x plus 1. That's it. So now I want my domain. But remember, domain, I go back to the original. So from the beginning, let's see, x cannot equal negative 1, positive 1, or negative 4. Right? So that's what x cannot equal. So I could write, if I wanted interval notation, negative infinity to negative 4. Union, negative 4 to negative 1, union, negative 1 to 1, union, 1 to infinity. And there we have it. All right, let's look at number 2. So number 2, 1 over x squared plus 9x divided by, so the very first thing I want to do, flip it. So I have 1 over x squared plus 9x times 3x squared minus 18x over 6 minus x. Okay? So now I'm ready to factor. 1 stays 1, x squared plus 9x. Pull an x out, and I have x plus 3, or sorry, x plus 9. Times 3x squared minus 18x. I can pull a 3x out, and I'm left with x minus 6. over 6 minus x, right? I can rewrite that as negative x plus 6, and then pull my negative 1 out, and I get x minus 6. Okay. So now what do I have like top and bottom? X minus 6. X minus 6, x minus 6. I have an x, and then I have an x. So then what do I have on top? 1 times 3, but I have negative on the bottom. So I have negative 3 on top over x plus 9. So that's what I get after I simplify my domain. Remember, I go back to the very beginning. So here I get x cannot equal 0, negative 9, or positive 6. Okay, so my domain, if I wanted interval notation, negative infinity to negative 9, union negative 9 to 0, union 0 to 6, union 6 to infinity. All right? Right, number 3. Again, very first thing, flip. So 2x squared minus 12x over x plus 5 times x plus 5 over x minus 6. Factor, so the only one I can factor is this one. Right? So if I pull a 2x out, then I'm left with x minus 6 over x plus 5 times x plus 5 over x minus 6. So x plus 5's cancel, x minus 6 cancel, and all I'm left with is 2x. My domain, again, back to the original, so here I get x cannot equal negative 5 or positive 6. So interval notation, negative infinity, negative 5, union, negative 5 to 6, union 6 to infinity. All right? So that's all there is to division. It's just like multiplication. It's just one extra step where we change it from a division problem to multiplication by flipping the denominator and multiplying by that. So now let's go to the back. I'm going to look at some word problems using division of rational expressions. So it tells me a company is evaluating two packaging options. I'm wrong, two packaging options for its product line. The more efficient design will have the lesser ratio of surface area to volume. So ratio surface area to volume, SA over V, that's what we're looking at, dividing. Should the company use packages that are cylinders or rectangular prisms? Okay, so here they show me a rectangular prism with a square base. So let's look at option 1. Option 1, and again, I'm doing SA over V. So they tell me the surface area is 2 times 2x squared, okay? So that's 2 times 2x squared becomes 4x squared, plus 4 times 2x squared becomes 4x squared, over volume 2x cubed. I have to cube all of that, so I get 8x cubed. So distribute up here on top, so I get 8x squared plus 16x squared over 8x cubed. I can combine like terms. 8x squared plus 16x squared is 24x squared over 8x cubed. Now, let's see, 8 goes into 24 3 times. X squared goes in x cubed, and I'm just left with x. So option 1 gets me 3 over x. This is option 1. That's my ratio. Let's check option 2's ratio. Option 2, our cylinder. So my surface area, okay, so we have 2 pi x squared plus, I'm going to go ahead and distribute that, 4 pi x squared over my volume. Again, I'm going to go ahead and distribute, so I would get 2 pi x cubed. And now let's, I can go ahead and combine on top, so I have 6 pi x squared over 2 pi x cubed. Now, let's start canceling. This 2 goes in that 6 3 times. My pi's cancel. X squared goes in there, x. So I'm left with 3 over x for option 2. What do I notice? They are equal, okay? The ratios are equal. Therefore, the company can choose which option they prefer. Okay, because their ratios are equal. All right, one more. The company compares the ratios of surface area to volume for two more containers. One is a rectangular prism, okay? So we're going to look at with the square base, rectangular prism, square base. The other is rectangular prism with rectangular base, okay? Rectangular prism, rectangular base. So let's draw the pictures of what these are going to look like. So this is like my cube. Okay. This is this. Okay. All right. So it says one side of the base is equal to the side length of the first container. Okay. So here my square base, if it's a square, I know it's the same all the way around, right? X, X, and X. So my rectangular base, one side of the base is equal to the side length of the first container. So there's my X. Let's see, the other side is twice as long. So this then would be 2X. The surface area of the second container, so surface area here, 4x squared plus 6xh. Then it tells me the heights of the two containers are equal, but over here I call my height x. So this is really just x. So my surface area here, I'm going to replace that h with an x. It's really 4x squared plus 6x times x. Okay. Which one has the smaller surface area to volume ratio? All right, so let's find the surface area of our rectangular prism with this square base. So that's going to be 2 times x squared plus 4 times x squared. And that's just using our formula for surface area. Okay. And again, I could pull that from right up here, right? They gave me surface area. It's 2 times the base squared plus 4 times the base squared. Here my base was 2x, here my base was just x. So my surface area here, 2x squared plus 4x squared, which is 6x squared. Okay? So now my volume of my first one, remember volume is just length times width times height. So here it's x times x times x, x cubed. So surface area over volume of my first one, 6x squared over x cubed. X squared, x, so I'm left with 6 over x. So now let's do the second one, the rectangular base, okay? So my surface area, I've got 4x squared plus 6x squared, 10x squared. My volume, again, my length times my width times my height. So I've got 2x cubed. So surface area ratio to volume. Over here I've got 10x squared over 2x cubed. 2 goes into 10 5 times. X squared, 5 over x. So, and it said which one has a smaller surface area to volume ratio? The second one, the rectangular prism with the rectangular base has the smaller SA to volume ratio. All right, that is day 2 of this, the division and word problems. So our homework today, the same worksheet from yesterday, the 4.3, only today we are doing problems number 27 to 32, 35, and 36. And you can find that worksheet in the announcements or underneath assignments. Envision worksheet 4.3. It will be due on Monday. Monday we will look at adding and subtracting rational expressions.